We're looking at geometry part 3 on circles unit, and it says on the top of the page I can convert a radius and center coordinates of a circle into an equation, and I can work in reverse to graph a circle. So we're going to work both directions, from the equation to the graph and from the graph to the equation. And in the process we're going to need to know the center, xy coordinates. We're also going to need to know the radius. So let's zoom in on number 2 for an example. If I am trying to find the center, I'm going to look at what is paired with x and what is paired with y in the squares. So if I am looking for the x coordinate, it is going to be what do I plug into that so that this whole group goes to 0. And in that case I would plug in a positive 3. Positive 3 minus 3 would go to 0. So x is 3. In this y coordinates, if I plugged in y equals -1, the opposite of that, is going to go to 0. So my center is going to be the point 3, -1. It says identify the center and radius of each. So that is the center. We actually want to write that out. The radius squared is over here. So that's equal to r squared, which means that our radius is equal to 3. So always remember that is not the radius, that is the radius squared. This is squared, this is squared, the radius is also squared. So I have my center of 3, -1. I have my radius of 3. To draw that on my graph, I go to the point 3, -1 right here, and I go out 3 in every direction. 3 up, down, left, and right. And I do my best to draw a nice clean circle here. And that would be your circle. So that would be how you graph it. When you're looking at number 4 and 5, we're not going to do those together. You want to use, in particular number 5, use the formula for area to work backwards to a radius. You'll have a center, you'll have a radius then you can use that to write the equation. Number 6 and 7, you can look at your graph to say, oh, I see the center of the circle. I'm going to use that, and I can figure out the radius by just 1, 2, 3, 4 by counting the boxes on the graph. And make sure your units are counting by 1. So in this case, we are counting by 1, so you can do that. So you'll do those on your own. For 8 and 9, it's a little more complicated. I'm going to focus in on number 9 because that's going to be the toughest one. You need to write an equation for this circle, but you do not have the center or the radius. All you are given is the ends of the diameter. I'm going to graph this just kind of in a sketch off to the side here. The point 1, 5, so I go over 1, up 5, and the point -1, up 3 would look something like this, roughly, on a graph. If that's the ends of the diameter, the center of my circle is somewhere in the middle. And my circle would go something like that. So that's kind of roughly what I'm looking at. I'm looking at a fairly small circle, and the center seems to be somewhere along the y-axis. To figure out exactly what it is, the center of the circle comes in the middle of the endpoints of the diameter. So if we're looking for the middle, we would find the midpoint. So center is midpoint. And to do our midpoint here, we look at our x coordinates and we say, what is the average of those? What is the average of 1 and -1? Add them together, divide by 2, and we get 0 divided by 2 is 0. We look at the average of 3 and 5. What is the average of 3 and 5? Add them together, divide by 2. You get 8 divided by 2 is 4. So that is the center of the circle, 0, 4. Now the radius is not the distance between the two endpoints of the diameter. That would give you the diameter. You want the radius. The radius is half of that. So you could find this distance and cut it in half. But an even safer bet is to go from the center to one of the ends. Let's pick this one because there's no negative numbers. It makes it a little less confusing. If we're going to calculate distance, we're going to say how far apart are the x's. Well, they are 1 apart. So 1 minus 0 is 1. And we're going to plug that into our Pythagorean theorem. How far apart are the y's? 5 and 4 are 1 apart. Take the square root of that. So we have 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. So the square root of 2 is the radius. One reason to do the radius as the distance from the center to one of the ends instead of half of the distance between the ends is sometimes cutting a root in half is actually difficult to do. So this is going to be the safer bet. So I know my center, I know my radius. To plug it into my circle formula, I'm always going to take x minus my x coordinate squared plus y minus my y coordinate squared is equal to my radius squared. Let's plug in those pieces. X minus my x coordinate, x minus 0. Y minus my y coordinate is y minus 4. My radius squared, if we were to take that and square it, square root of 2 squared is just 2. It is not 4. You could say it's the square root of 4, but what's the square root of 4? It's 2. So you could write it like this, and if you wanted to clean that up even further, x minus 0 is just x squared, and then y minus 4 squared equals 2. So that's going to be the most cleaned up version of your formula for a circle. So that one's the toughest one, but you're going to see problems similar to that on other sections.